So it's right at the flagpole.
Okay, so this actually just really comes on the heels of all of the 3-cell model stuff we've been talking about. You're going to want to remember those semi-permanent highs that are right here, where basically the Hadley cell is descending, and the semi-permanent lows where the Farrell cell is ascending. So the other thing about it is we're switching gears from winds to ocean currents. The only reason that water moves is actually because wind is moving over top of it. And the cool thing is that actually the farther down you get into the ocean, it stops moving, because basically it's moving fastest here at the surface and it gets slower and slower as you go down. So the only reason that what creates these large oceans, ocean water gyres, little currents add together to make a large ocean gyrate, is actually the wind on top of the water. So yeah, we're going to talk more about the Bermuda High. Okay, kind of there between the Hadley and the Farrell cell. And as we look at as we remember the wind, basically, like I said, the water underneath the prevailing wind moves in the same direction. So it's all about, and the theme is, because of the Coriolis force, deflection to the right, it's all about, in the northern hemisphere, around a high, it will be clockwise motion, and around a low, it will be counterclockwise motion. So, let's see, high, clockwise, northern hemisphere. In the southern hemisphere, it would be counterclockwise. Great. So just in general then, these are kind of segmented ocean gyres. It says, can you pick out the 5 ocean gyres? So basically, they don't go beyond the equator for obvious reasons maybe. We actually have, let's see, what color do I want to pick? Purple, yeah. There's 1. There's 2. Okay, this one actually is a part of, it wraps around. That's part of the North Pacific gyre. Okay, then we have a South Pacific, a South Atlantic, and an Indian Ocean. So like I said, the ocean gyre is actually made up of separate currents. We're going to spend a little bit of time focusing, when we talk about El Nino, La Nina, actually we are going to focus on this neck of the woods to decide if we're in an El Nino or a La Nina event. So kind of pay attention. You're going to hear me talk about the Peruvian current, or your textbook talk about the Peruvian current. It's a cold current. Notice that it's part of the South Pacific Ocean gyre. And actually, you know, if we switch hemispheres, if there's a semi-permanent high there, which there is, the descending part of the Hadley cell, then motion must be counterclockwise. And can you see the counterclockwise around that high? I can. All right. So in order to kind of understand El Nino, La Nina, and if you've done much with this, you know that actually that goes back and forth, El Nino, La Nina, El Nino. We need to understand something called upwelling. Aside from La Nina, El Nino, upwelling is important. If you live on the coast, you are counting on upwelling. It's kind of like it sounds. Basically, it's water coming up from the ocean depths along the coast, and it brings cold water, which is cool, it's nice, and it also brings nutrients for the little fish, okay, so fishermen need it. Okay. So upwelling is a good thing. Upwelling actually is caused by kind of I think of it as almost kind of a suction of water. Prevailing wind basically makes the water go out, and the water is replaced with water from below. So upwelling is a good thing. So I changed this figure. This figure might be different than the one you have. It's a figure from your textbook, and it talks about normal conditions. Remember I told you we'd be focusing on South America, the Peruvian current and all that? Okay, that's over here. Okay, so this is what, the South Pacific? Change my color to purple. South Pacific. ocean gyre, to kind of put things in perspective. Right here, think of right here as your intertropical convergence zone, your ITZZ. So that is actually where your two Hadley cells are butting up against each other. Okay? So that kind of sets the stage. We have upwelling is going on right there. Upwelling. That's a healthy sign. And actually, it's all consistent with what we've been talking about. Because can you see the prevailing ocean current there? It's because of the prevailing wind, which is actually these trade winds. Okay, that's what you're seeing right there. Right, and it makes upwelling occur off the west coast of South America. Everybody's happy. That's normal conditions. Notice that under normal conditions, we basically have kind of a high pressure here, a low pressure here, air is converging, it's ascending, and as it rises, it expands and cools, and it's nice and moist, and so we definitely have precipitation here. By the way, sometimes you'll hear, and I don't know if your textbook does it, maybe it does, but sometimes you'll hear this called the Walker cell in that neck of the woods. It's kind of a three-dimensional thing. All right. Cool. Well, what happens in an El Nino? An El Nino event, right off the bat, if you compare what you just saw with what's happening down here, check that out. I don't see any easterly trade winds, do you? If that is our ITCZ, what happened? Okay, it's called an El Nino condition. So if you're asked on a test to describe this, you know, I usually describe it that basically those easterly trades reverse themselves. These were supposed to be easterly trade winds. Okay, so you're like, really? Oh my gosh. Well, I can't really focus on why it happens. I do know that El Nino goes back and forth with La Nina condition. We'll talk about La Nina here in a minute. But what we do know is it has condition, or it has an effect globally. But if we just focus on what's happening over there, what happened to your upwelling? There is no upwelling. So your upwelling ceases. Welling ceases. Okay? Why? Because you don't have that current going out and kind of bringing up cold water. So it makes the fisherman crabby, it makes the fish crabby, okay? The other thing is check out where the clouds are. There's no clouds over here, and there's clouds over here. You're like, dude. So compare the normal to the El Nino. El Nino, dang it, okay? Notice that they can last for a while, you know? So that's it. That's El Nino. Okay, so what I wrote on the slide is it shuts down the upwelling. Goodness, I won't type this. Okay, so they lose their cold water and their nutrition. We saw them get dumped on precipitation instead of being dry like normal conditions. Okay, and the other thing is at the other end of the Walker cell. Okay, Australia's used to getting dumped on, and Australia and the Indonesian islands, and in an El Nino condition, they've got to start walking their boats places because the water level really goes down. Okay, so I think your book has a table maybe that when this is a world thing. I know it looks really local, you know, because I'm just describing it kind of between South America and Australia, Indonesia, but literally it's a global thing. Okay, so other places are affected too. Notice, and sometimes I find this interesting because different conditions make hurricanes favor hurricanes, they disfavor tornadoes. If they favor tornadoes, they disfavor hurricanes. So actually El Nino will actually disfavor hurricanes. So hurricane activity, I'll put hurricane activity down. El Nino.
Is there a way that was
Could be, I don't know. So here we see kind of the normal conditions. This is the slide you saw a minute ago. Okay, and this is a different figure from your, this is a figure I think from your textbook. I think I snagged the other one from the internet. This actually is, this is showing you El Nino, and it's not really showing you the countercurrent strong per se, but those easterly trades are at least weakened. And you see over in El Nino again, you see kind of the thunderstorm cloud is over here, South America, instead of where it should be, El Nino. All right, so now we're going to talk, or we need to spend a minute talking about La Nina. So if you know, and I don't know anything about Spanish, but that's the masculine and the feminine of the kind of the little child sort of thing. So La Nina, when I show you a picture here, or maybe I don't have a picture, sorry. Not going to show you a picture. But basically, it's reversed conditions. Okay. So if I were to go ahead and I'll choose this green marker, oh, I don't know. Well, La Nina, I don't have a picture of it, like I said. But La Nina is just the opposite in that, remember with an El Nino, the easterly trades like almost reverse themselves? Well, with the La Nina, the easterly trades intensify. So think of what would happen if those easterly trades intensified. Well, the fish would be extra happy because they get extra nutrients. Okay, so actually upwelling goes in overdrive. Think of it that way. Okay, it's enhanced. So basically they get even colder than usual temperatures on the west coast of South America. Okay, they get even less rain than usual. Okay, and then the precipitation we saw under normal conditions over Australia and Indonesia, it's enhanced too. Okay, and so speaking of enhancement, okay, by the way, some of you may or may not know the term tropical cyclone is the generic term for what we around here call hurricanes. So the same thing. Okay, so hurricanes actually like La Nina events. So here's my hot link that actually it's going to take us out to see what the current conditions are. If it wants to stop. I think this was updated. It says March 5th. We'll just have to go with it. March 5th this year anyway. Notice they're saying that currently we're in an El Nino conditions. And one of the last things I want to talk about is how do we know which condition we're in? You might already kind of have an idea. But one way we can do a temperature check. So of course red is hot, right? So we said a little bit ago during an El Nino event, you don't have that nice easterly trades that give you good upwelling. So the reason this is so hot here, okay, is because we have no upwelling. No upwelling. That's why. Okay, so a check there would show you surface temperatures. And if you kind of get your bearings about you, I don't know, but over here, I don't think there's another landmass. That might be an Indonesian island, I don't know. But Australia's over here. Over somewhere. Okay, so La Nina, I said basically those easterly trade winds go crazy. Okay, and if the easterly trade winds blow even faster, then we have lots of upwelling. And with lots of upwelling, you would expect extra cold, and that's kind of what we're seeing here. So temperature is one way. This says, actually at the top here, it says how do meteorologists track which condition we're in? They do the surface temperatures like you saw. They can look at pressures. They can look at the meridional or zonal flow. Okay. And they can look at temperatures and cloudiness. So here you see the red is the El Nino. This is El, and this is La. So you can kind of see how they go back and forth. And we said La, and this goes back to what Arlen was saying. So La Nina, it favors hurricanes. Favors hurricanes. So you could go check. Very good. All right. Well, I'm not going to go ahead and start, but know that in 2 weeks we have our work cut out for us to do air masses, and we'll talk about weather fronts and mid-latitude cyclones.
And that's when I would assume 6 and 7 will be due?
Thank you. Yes. Since we got through 6